Example 1. The sum of two positive numbers is 50. Find their product as large as possible. We have step 1. Our x will be our first number, y will be our second number, and p is for the product. Next, we have our constraint here. X plus y is equals to 50, and our objective is x times y is equals to p, or the product. Solve for y. In order to solve for the y, we're going to use the constraint. X plus y is equals to 50. We're going to transpose the x to the other side, and it will become negative x. So our equation number 1 is y is equals to 50 minus x. Number 3. Substitute equation 1 to objective. P is equals to x times y. Copy P is equals to x, and our equation 1 is 50 minus x. So it will become P is equals to 50 times x is equals to 50x. X times negative x is equals to negative x squared.
Finding the derivative of 50x minus x squared. So the derivative of 50x is 50, since the x is equal to 1. Then in negative x squared, we need to use the power rule. So it will be equal to negative 2x. And by the way, we use the formula of d4 in sum and difference of function. So after the answer 50 minus 2x, after that we need to transpose the negative 2x to the other side. So it will become positive 2x equals 50. So to become the 2 will become x, we need to divide it by 2 and the 50 also. So 2x divided by 2 will be x. Then 50 divided by 2 will become 25. So our x here is equals to 25. Now that we had found the value of x, in which is the value of x is 25. So let us proceed to the next step. And the next step is solve for y. So to get the value of y, use the formula y equals 50x. Then substitute the x to 25. So 50 minus 25 is equals to 25. So the y is equals to 25. So in conclusion, since x equals 25 and y equals 25 also, therefore the maximum product is 625.
So the second problem is the area of a rectangular fence is 128 meters. So what would be its parameter at its minimum? So the first step to find the parameter and its minimum is solution in drawing. So x is equals to the length, y is equals to the width, and p is equals to the parameter. xy is equals to 128 constraint, and 2 times x plus y is equals to the parameter, and that is the objective. The next step is to solve for y. So y is equals to 128 over x, that is the equation 1. Step 3, substitute equation 1 to the objective. So parameter is equals to 2 times x plus y, so p is equals to 2 times x plus 128 over x. So p is equals to 2x plus 256 over x.
After we substitute equation 1 to the objective, which is p equals to 2x plus 256 over x, we will find its first derivative. So p is equals to 2x plus 256 over x will turn into d over dx times 2x plus d over dx times 256 over x. D over dx times 2x is equals to 2, while d over dx times 256 over x is equals to negative 256 over x squared. And that's our first derivative. After we get the derivative, we will solve for the x, which we transpose, changing it to 256 over x squared equals to 2. We need to remove the x squared below 256, so we need to multiply both sides by x squared. So it will turn out to 256 over x squared times x squared equals to 2x times x squared. Cancel out the x squareds and we will have 256 is equals to 2x squared. Now we need to remove the 2, so we divide both sides by 2. So 256 divided by 2 or over by 2 is equals to 2x squared over 2, and we will get the 128 equals to x squared. Since it is x squared, we need to find its square root. We square both sides, so we will have the square root of 128 equals to the square root of x squared, and the answer is x equals to 8 times to the square root of 2. Now, since we have our x, we need to solve for y when x is equals to 8 times to the square root of 2 by using our y. Y is equals to 128 over 8 times to the square root of 2. By using our calculator, we will get our answer, which is y is equals to 11.314, or the original answer is 11.3137085, which is also 8 times to the square root of 2. Now we have our x and y, we can make our conclusion. Since x and y are 8 times the square root of 2, or 11.3137085, therefore the minimum parameter of the rectangular fence is 45.26 meters.